Have you ever noticed those subtle shifts as the years pass by? Perhaps it's a general sense of fatigue, that widening part line on your scalp, a few more hairs gathering in the shower, drain, or even just feeling a bit less resilient and capable than you once did. A subtle stiffness in the morning making simple tasks feel harder. It's a common experience, and often we simply attribute it to getting older. We assume this gradual decline in vitality is inevitable, an unchangeable part of the journey. But what if we've been missing a crucial piece of the puzzle? What if some of these changes, the ones that make us feel less vibrant, aren't just about chronological age itself, but about an overlooked internal conversation happening within our bodies? Today, we're going to explore how one fundamental aspect of your physiology, something often thought of just for strength or aesthetics, plays a profound and unexpected role in not just how long you live, but how well you live. We'll delve into the incredible metabolic and communicative power of your muscles and uncover how supporting them can truly help you feel like the healthiest, most energized version of yourself, regardless of your chronological age. It turns out your muscles are far more than just what helps you move or lift things. They are truly dynamic, metabolic powerhouses, acting as crucial command centers in your body's energy landscape. Think of them not just as structures, but as the primary customers for the vast majority of the sugars, fats, and proteins you consume. They're constantly ready to process these nutrients, converting them into the energy your body needs to thrive. Active muscle tissue significantly contributes to your basal metabolic rate, promoting a healthy metabolism and body weight throughout your lifespan. One of their most remarkable functions is as the main storage reservoir for the glucose you get from your diet. When you eat carbohydrates, glucose enters your bloodstream. Your muscles efficiently take up this excess glucose and convert it into a stored form called glycogen. This glycogen acts like a personal fuel tank within each muscle cell, ready to be tapped for immediate energy during physical activity. What this means practically is that healthy, active muscles are incredibly effective at managing your blood sugar levels, preventing unhealthy spikes and supporting overall metabolic balance. This capacity is particularly critical in metabolic health. Now, here's where it gets interesting. When you engage in physical activity, especially sustained efforts, your muscles first draw upon this readily available glycogen. But once those glycogen stores are depleted, your body, and specifically your muscle cells, intelligently shift gears. They begin to seek alternative energy sources, primarily drawing upon free fatty acids stored in your adipose tissue and, crucially, ketones, PTIM fat breakdown. This metabolic flexibility, the ability to efficiently switch between burning glucose, fat, and ketones, is a cornerstone of long-term health and cellular resilience. This metabolic adaptation leads to profound changes within your muscle cells, particularly in tiny organelles called mitochondria, the powerhouses of the cell. When utilizing fatty acids and ketones, mitochondria can become remarkably efficient. This process can lead to what's known as mitochondrial uncoupling, meaning your mitochondria become more robust, produce energy more efficiently, and can even increase in number. Uncoupling helps dissipate excess energy as heat, protecting mitochondria from damage and extending their functional lifespan. In practical terms, this supports a more resilient cellular system, enhancing ATP energy production, optimizing cellular waste removal, and promoting overall cellular longevity. Beyond their role in energy metabolism, muscles are also sophisticated endocrine organs. They produce and release special signaling molecules called myokines, into your bloodstream in response to contraction. These aren't just local messengers. They act like hormones communicating with distant organs. One of the most fascinating discoveries is the profound impact these myokines have on brain health. Research indicates myokines, such as brain-derived neurotrophic factor, BDNF, play a vital role in promoting neurogenesis, the creation of new neurons, and supporting the overall function of your brain, including memory and learning. They can also cross the blood-brain barrier, exerting direct protective effects. In essence, active musculature sends direct, beneficial signals to your brain, fostering cognitive health, improving mood, and enhancing neuroplasticity. This explains why studies show physically active individuals maintaining muscle mass into late life tend to exhibit superior cognitive function and a lower risk of neurodegenerative conditions. It's a clear biological link. Happy muscles truly contribute to a healthy brain. This recognition helps us understand why we so often see centenarians, those who live to be 100 and beyond, characterized not by intense gym routines, but by consistent natural movement throughout their day. They aren't gym rats in the conventional sense. Instead, their remarkable longevity is often intertwined with lives that simply demand regular, varied physical engagement. Walking for errands, tending to gardens, with manual effort, herding animals, climbing stairs multiple times a day, or even vigorous household chores like scrubbing floors. Think of how a daily walk up and down hilly terrain, or consciously choosing stairs over an elevator, continuously engages and strengthens your musculature, building functional strength and cardiovascular fitness implicitly. My own mother found joy and sustained activity in the physical effort of housework, and my great-grandmother, living independently to nearly 100, intuitively benefited from navigating a 3-story home using stairs multiple times a day as a natural, integrated form of exercise. These aren't just anecdotal observations, they represent a fundamental principle of human physiology. Our bodies are designed for regular, varied movement, not prolonged periods of sedentary behavior, punctuated by occasional intense workouts. This continuous low-level activity, often called non-exercise activity thermogenesis, NEAT, is incredibly powerful for overall health. What this looks like day to day is an integration of movement into your existing routine, seeking opportunities for physical engagement rather than avoidance. It's about resisting the modern conveniences that tempt us to minimize physical effort. When advertisements promote gadgets that promise to eliminate bending, reaching, or walking even short distances, they inadvertently detract from the very small, consistent efforts vital for long-term health and vitality. The secret truly lies in keeping your body in motion throughout the day, every day, by embracing practical, purposeful movement. Another important factor often overlooked is the specific type of walking you engage in. For cardiovascular health, a brisk pace that challenges your breathing and makes conversation difficult is ideal, perhaps on an incline to increase strain. This stimulates a specific physiological response. However, walking more slowly can be incredibly beneficial for problem-solving or fostering social connection. This is particularly evident in some cultures, like those found in blue zones, where a daily post-dinner stroll, known as the pasagyata, is a cherished social ritual. This slower pace helps to stabilize blood sugar after a meal and promotes community interaction, which is another crucial yet often underestimated aspect of longevity. In fact, many of the blue zones, areas where people live exceptionally long, healthy lives, are found in hilly communities where walking is an integral part of daily life, long before cars became ubiquitous. And while walking might not build large biceps, it's exceptionally good for your leg muscles, particularly the calves. The calf muscles are often called your second heart because they play a vital role in circulation. When you stand for long periods, blood can pool in your feet, leading to reduced circulation and swelling. But as you walk, your calf muscles contract and relax, acting as a pump to push deoxygenated blood back up towards your heart, countering gravity. This mechanism helps maintain blood pressure and prevents issues like fainting or chronic edema. Continuous movement, even walking, is fundamental for healthy circulation throughout your body. Now, let's address a common concern that arises as we age, particularly around the age of 65, the idea that our protein requirements dramatically increase protein requirements. While studies suggest older adults need more protein to maintain muscle, the true challenge might not be a simple lack of intake, but rather a diminished ability to absorb and utilize the protein we consume. This decline in digestive efficiency makes it seem like more protein is needed when assimilation is the core issue. This is where many people are surprised. Our gut surface area, where nutrient absorption occurs, is truly enormous, equivalent to a tennis court when healthy thanks to countless folds and microscopic villi. However, over decades, this vital surface can be significantly compromised. Dietary components like asterisk lectins, found in grains, legumes, and some vegetables, along with other disruptors such as certain medications, processed foods, and chronic stress, can cumulatively damage the delicate lining of your gut, the gut barrier. This damage reduces functional surface area, impairing your body's capacity to efficiently extract amino acids from proteins. Imagine trying to absorb nutrients from a tennis court, only to find yourself with the capacity of a ping pong table. This impacts not just protein, but many vital micronutrients. As a heart surgeon, I observed elderly patients with low levels of total protein and albumin. Albumin asterisk. A major liver-produced protein is crucial for transport and fluid balance, making its depletion a marker of risk. The conventional assumption was these individuals needed more protein. However, my clinical experience revealed a different truth. When we focused on healing and restoring their gut barrier by adjusting diet, reducing gut-damaging foods, their protein and albumin levels normalized, even with lower protein intake. This suggests the perceived need for more protein in older age often masks a compromised gut's inability to assimilate. The real key isn't necessarily to force-feed more protein, but to repair and optimize your gut lining. You're only as healthy and as capable of building muscle as your gut wall is intact and functional. A healthy gut barrier prevents undigested food particles and toxins from entering the bloodstream, reducing systemic inflammation, a critical factor in healthy aging. By removing gut-damaging compounds and focusing on gut-supportive nutrition, you enable your body to effectively absorb and utilize protein, naturally supporting muscle health without excessive intake. It's about smarter, more efficient absorption. Now this is where it gets interesting, connecting these concepts to how and when we eat. The science of intermittent fasting or time-restricted eating provides compelling insights into optimizing muscle health and overall longevity. Consider a notable Italian cyclist study. 2 groups of athletes consumed the exact same number of calories and followed identical training regimens over 3 months. The crucial difference was their eating window. One group ate over a 12-hour period, while the other compressed their meals into a 7-hour window. Strikingly, the group with the shorter eating window maintained muscle mass and performance, lost weight, and significantly, experienced a substantial drop in insulin-like growth factor 1, IGF-1. This reduction in IGF-1, a powerful growth-promoting hormone, is often associated with enhanced longevity. IGF-1 is a key hormone in growth and metabolism. While essential, chronically elevated levels have been linked to accelerated aging pathways and increased risk for chronic diseases. By limiting the eating window, these athletes weren't just losing weight, they were tapping into metabolic pathways that optimize cellular repair and longevity, likely including processes like autophagy, the body's cellular cleanup system. This means structured eating patterns can influence systemic signals like IGF-1, promoting cellular efficiency, enhancing cellular repair, and potentially extending health span, even with consistent protein and calories. It's a powerful demonstration of how when you eat can be as important as what you eat. Furthermore, digestion is incredibly energy intensive. It demands significant resources, including blood flow and metabolic energy, which could otherwise be directed towards muscle repair and synthesis. Roughly 30% of your cardiac output can be diverted to the digestive system after a large meal. This provides a strong rationale for an effective strategy. Exercising on an empty stomach, followed by a meal. When your muscles are hungry from a fasted workout, they become incredibly receptive to nutrients, primed to absorb amino acids and glucose more efficiently, channeling resources directly into repair and growth. Think of it like this. Your muscles are primed after a fasted workout, acutely sensitive to nutrient reintroduction. Protein and carbohydrates introduced at this specific time are rapidly taken up and utilized for immediate repair and rebuilding. This principle is not unlike blood flow restriction training, where muscles work under low oxygen, then are flooded with nutrients for enhanced growth. You can achieve a similar physiological advantage simply by timing your meals around your exercise. Hydration remains critical during any fasted exercise, and you don't need grueling hours-long gym sessions. Even short, consistent bursts of movement throughout the day can be highly effective. A brisk walk, a few minutes of jumping jacks, deep knee bends while brushing your teeth, or dancing to a favorite song. These energy snacks activate muscles, initiate glycogen depletion, and prime your body for metabolic advantages. The key is consistent stimulus, activating those muscle fibers and signaling pathways regularly, not overwhelming intensity or prolonged duration. Another area often surrounded by misconceptions is the source of our protein, particularly the debate between plant and animal proteins. There's a pervasive myth that significant muscle mass can only be built or maintained through animal protein. However, a quick look at some of nature's strongest creatures, like gorillas or horses, clearly demonstrates immense muscle strength can be forged entirely on a plant-based diet. They consume only plants, yet possess extraordinary musculature, a powerful testament to the efficacy of plant-derived nutrients. The challenge for many vegetarians or vegans isn't the inherent inadequacy of plant protein, but often an underlying issue with gut health. If gut damage from lectin-containing foods or other disruptors impairs nutrient absorption, any dietary protein will be less effective. For a healthy gut, however, ample high-quality plant protein is readily available, often bringing additional benefits like fiber and diverse micronutrients. For example, 1 ounce of many common vegetables can provide about 2 grams of protein. But we can be more strategic. Consider incorporating low-lectin, healthy plant protein choices. Pressure-cooked lentils and beans are excellent. Lentils, for instance, are primarily protein and pack an impressive 15 grams of gut-friendly fiber per cup, vital for a healthy microbiome. Hemp products such as hemp tofu or hemp hearts are versatile, easily sprinkled on salads, vegetables, or added to smoothies, providing a complete amino acid profile. Many nuts and seeds are also protein powerhouses, offering 4 to 9 grams per serving, along with a full spectrum of essential amino acids and healthy fats. Barrownuts and sacho-oenchi seeds stand out for their exceptionally high protein content and are naturally low in lectins. Moreover, quality plant-based protein powders from spirulina, algae, flaxseed, and hemp offer convenient ways to boost intake. For plant-based diets, ensuring adequate B12 and iron is also important through supplementation or fortified foods. This next piece explains why focusing on plant proteins can be particularly beneficial for longevity. Research suggests certain amino acid profiles in animal proteins, while crucial for growth, may also, when consumed in excess over a lifetime, subtly accelerate aging pathways linked to continuous mTOR activation. Plant proteins, in contrast, tend to offer a more balanced profile that supports muscle synthesis while potentially downregulating some strong growth-promoting, aging-accelerating signals. Prioritizing diverse plant protein sources is not just about muscle. It's about optimizing your internal cellular environment for a longer, healthier, health span. Let's delve deeper into the complex interplay between protein, muscle, and a critical cellular pathway known as mTOR, or the mechanistic target of rapamycin. It's tempting to think that simply eating more protein automatically translates to more muscle, but that's a common misconception. Muscle growth is a dynamic process requiring not only dietary protein with its specific amino acid components, but also the crucial stimulus of physical activity, particularly resistance training. Without that mechanical stimulus, excess protein can be inefficiently used or converted into glucose via gluconeogenesis in the liver and subsequently stored as fat rather than actively building muscle. While protein is essential, more isn't always better beyond a functional threshold. Intelligent utilization is key. The current recommended dietary allowance, RDA, for protein, typically around 0.8 grams per kilogram of body weight, was primarily established to prevent acute protein deficiency. However, this minimum is often insufficient to support optimal muscle health and counteract age-related muscle loss, known as sarcopenia. Our bodies constantly engage in protein turnover, a continuous process of breaking down old proteins and synthesizing new ones. This intricate process becomes less efficient with age due to anabolic resistance, meaning older muscles require a stronger stimulus and higher amino acid availability to initiate protein synthesis. Consequently, studies consistently demonstrate that individuals who increase their protein intake slightly above the RDA, perhaps to 1.90 to 1, 2 grams per kilogram, experience significantly better outcomes, including improved blood sugar regulation, healthier triglyceride levels, better blood pressure, and enhanced insulin sensitivity, all contributing to metabolic resilience. This isn't about excess. It's about providing adequate bioavailable building blocks to counteract age-related declines in protein synthesis. Stay with me here because this matters. TOR is a central cellular pathway that precisely senses nutrient availability, particularly specific amino acids like leucine from protein, regulating cell growth, proliferation, and survival. It's often viewed as a fundamental growth switch. While mTOR activation is undeniably essential for muscle building, especially after exercise, chronic, continuous activation of mTOR, particularly without intermittent periods of rest or physical demand, is increasingly linked to accelerated cellular aging and various chronic diseases. Continuous signaling can lead to cellular senescence, where cells stop dividing and release inflammatory compounds. Drugs like rapamycin, which suppress mTOR, are being studied for their potential longevity-promoting effects, highlighting the importance of managing this pathway. Interestingly, when we examine the longest-lived individuals globally, we often find they have relatively low levels of insulin-like growth factor 1, IGF-1, a hormone closely tied to mTOR activation and growth pathways. This observation, combined with studies like the Italian cyclist trial we discussed, where time-restricted eating lowered IGF-1 without compromising muscle mass, paints a nuanced picture. It suggests that while we need to stimulate more for muscle repair and growth, we also need deliberate periods when it can reset and be less active, allowing for essential cellular maintenance and repair processes like autophagy to occur. The key understanding is that mTOR signaling is highly tissue-specific and context-dependent. mTOR in your liver, for instance, might be exquisitely sensitive to insulin and carbohydrate intake, while mTOR in your skeletal muscle is primarily sensitive to specific essential amino acids, and crucially, the mechanical stimulus of exercise. Therefore, we can't simply label mTOR activation as universally good or bad. The most detrimental scenario is continuous low-level activation across all tissues, often driven by constant snacking, nutrient overload, and an imbalance of carbohydrates and proteins throughout the day. Conversely, a highly beneficial approach involves pulse stimulation of mTOR primarily within skeletal muscle, achieved through strategic time protein intake and focus resistance exercise. This creates an on-off switch mechanism. You activate mTOR in your muscles for growth and repair when needed, allowing for robust protein synthesis, and then allow it to return to a more resting state during periods of fasting or lower nutrient availability. This cyclical activation and deactivation appears crucial for cellular longevity, promoting optimal metabolic health and supporting the body's natural repair mechanisms. This synergy between timed eating, appropriate high-quality protein, and consistent physical activity allows you to optimize muscle health while simultaneously supporting healthy aging pathways. This intricate dance between movement, strategic nutrition, and sophisticated cellular signaling underscores a profound truth. Your physical vitality isn't isolated to individual systems. It's a symphony of interconnected processes. Optimal muscle health, for instance, is deeply intertwined with hormonal balance. As muscles influence and respond to key hormones like insulin and growth factors, it profoundly impacts your stress physiology, as regular activity can modulate cortisol levels and enhance resilience. Your asterisk sleep quality significantly benefits from consistent movement, which helps regulate circadian rhythms, and critically, good restorative sleep is crucial for muscle repair and growth. Effective asterisk circulation is paramount, ensuring nutrients reach muscle tissue and waste products are removed, and as we've discussed, even purposeful walking plays a key role, particularly with your calf muscles acting as a second heart to pump blood back to the core. Furthermore, reducing gut inflammation and fostering a healthy microbiome directly enhances asterisk nutrient absorption, foundational for muscle protein synthesis. Ultimately, fostering robust muscle health through these integrated approaches is a powerful pathway to improving systemic balance across all these critical physiological domains, leading to a more resilient, energetic, and vibrant you. As you embark on incorporating these principles, it's vital to calibrate your asterisk expectations realistically. Biological change, particularly at a cellular and muscular level, operates on its own timeline. You'll likely experience asterisk internal shifts, improvements in energy, sleep, or digestion long before you see dramatic external changes in muscle definition or body composition. This journey emphasizes asterisk consistency over intensity. Asterisk consistency over intensity. Small, regular efforts, sustained over weeks and months, yield far more significant and lasting benefits than sporadic, strenuous bursts. It's about building sustainable habits that honor your body's physiology. Understanding that progress is a gradual, cumulative process rather than an overnight transformation. If you found this discussion insightful, please consider subscribing to our channel for more deep dives into optimizing your health. And we'd love to hear from you in the comments below. Share your current age and one health concern or question you'd like us to explore in future videos. This content is educational only and not medical advice. For persistent concern,